Hello, in this video we're going to take a look at dimensions. Okay, so this is an interesting objective. Let's see if we can understand a few things about dimensions. Now, you've probably seen a few formulas here and there. Let's think about a few of them now. Okay, so if we had a rectangle and I called this L and W for length and width, then I could say for sure that the perimeter is 2 of those W's plus 2 of those L's, right? Okay. The formula for circumference of a circle is going to be, if we have the radius there, look, okay, the circumference is going to be 2 pi r. And if we think about maybe a square, okay, with L there, look, as the length of the side, then the formula for the perimeter of this is 4L. Okay, now all of these formulas have something in common. Yes, they're all for a length unit. They're all working out perimeter and circumference is really a measure of length. So therefore, we're going to have sort of centimeters or meters as our units. But really importantly, they all have a dimension of 1. Now, what does that mean? Well, they each have one variable, right? And that has a dimension of 1. So if we think about it, look, R is a length, L is a length, and they're just being multiplied by numbers. So therefore, the answers are lengths. This makes perfect sense, right? Okay. Even in this top example, you may be thinking, well, okay, no, hang on a second. There's 2 there, look, because W and L. Well, think about W as a length. Well, doubling it is a length. Think about L as a length. Well, doubling that is also a length. And if I have 2 lengths adding together, that's still going to be a length, right? Okay, all straightforward stuff. So we say each of these formulas has dimension of 1. Okay, now let's think about some formulas for area, right? Okay, well, the area of that rectangle is WL or LW, right? The area of a circle is going to be pi r squared, and the area of that square is L squared, right? L times L. So what do these 3 formulas have in common? Well, they each have a length multiplied by another length, right? W times L, or in that circumference area circle example, R times R, right? It's still the same thing. It's a length times a length, right? There they are, R times R. And it's exactly the same, for that area of the square. It's L times L. So when we have 2 lengths multiplying together, we say we have dimension 2, right? Okay, there are 2 dimensions to that. That is therefore going to all have a similar sort of unit, centimeters squared or meters squared or something like that, right? A square unit. Final example, right? Okay, let's think about a few others. Well, if we have a sphere, okay, then the volume of a sphere is 4/3 pi r cubed, right? If I have a cube, length L, then the volume is going to be L cubed. If I have a cuboid like this, and we have length times, I don't know, width times height, then the volume is LHW, right? It's okay. And in each of these 3 scenarios, we have dimension of 3 because we have length times length times length happening, right? Okay, R is a length and it's timesing by itself 3 times here, right? 4/3 pi, that's just a number. It doesn't make any difference to the number of dimensions. But we've got R times R times R. This is what's helping us to understand it has dimension 3. It's the same here, look, L times L times L, 3 lengths multiplying together. It's the same in this example here, L times H times W, 3 lengths multiplying together. So what we're going to do is we're going to be using this idea to help us to classify and look at formula to decide if they're formula for lengths, for areas, or volumes. So let's take a little look at this example here. Okay, we'll go through each of these 5 questions and see if each expression could be for a length, an area, or a volume. So let's take A. How many lengths do we have multiplying together? Well, this one, okay, if I just had x on its own, if x, look, is a length, and y is a length, and z is a length, well, if I add them together, I've just got a bigger length. This is going to be a length, okay, right? It's a formula that's going to be, give me a solution in centimeters or meters, right? It's going to be a length. Let's think about x, y, z in part B. Well, here we've got three lengths multiplying together. So just as we saw earlier, this is going to have to be something that gives us a volume. Now, C is very tricky because clearly y is a length, right? No problem with that. But what about x over z? Well, if I have a length divided by another length, and they're both length units, it's going to kind of cancel out. It's not going to give us, it's going to have a dimension of 0, right? Okay. So therefore, this whole, you can't add a numerical value to a length, okay? It doesn't make any sense from a geometric perspective. So this is none of the above, right? It doesn't make any sense. In the same way, if we look at part D, right, we have this top part has a dimension of 2, right? That, if it was just x times y, that would be an area. But we're dividing by z. So overall, that kind of cancels out, right? We're going to have a length. This has dimension of 1, right? Because one of the dimensions on the top cancels with the bottom there. Finally, each of these three parts individually are areas, right? Because they have dimension 2, length timesing by length. But if I'm adding them together, what happens? Well, if I add areas together, I just get a bigger area. It's still an area formula. So hopefully that's helped you to understand a little bit more. Maybe we could try a few even more complex examples. So I'm just going to write L, A, or V for these. Let's do these simple ones first, right? Well, first of all, A has to be for an area because we have a length multiplied by a length. And can we see any other obvious ones here? Well, let's just quickly take a look at that last one, I, right? Well, if X, Y, and Z are all lengths, then, and 2, that's just a number. That's not going to do much, is it? Okay, then if this one is going to have to be a volume because length times length times length, that makes volume. All these other ones are really complex, so let's see if we can break this down. And remember what we said about fractions. They're going to cancel, right? Okay, so they're going to cancel dimensions. So the x is dimension 1, but when I divide it by another element that has a dimension of 1, it cancels out. That means this is just a number, okay? This is not going to have any dimension to it. So we'll write n for none. This one in part C, we have on the top, we have x times y times y. Well, that has 4 dimensions, but we're dividing by a z, and that's going to kind of cancel out one of those dimensions, leaving us with just 3. So this is a volume. In D, for exactly the same reason, can you think what this is going to be? It's going to have to be an area because there's a dimension on the bottom cancelling with 1 on the top. E, for the same sort of reasons, well, this is going to have to be an area as well. Okay. Now, F is a tricky one. Okay. This has dimension of 0. It's not a length, area, or volume. It's just going to give us a number. So does this. So it's not any of them. Also, in G, this part is a volume, but this part is a length. Now, you can't add a length to a volume. It makes no geometric sense. So when this happens, we say it's none of them. Absolutely none of them. H is a volume because we've got 4 dimensions on the top, 1 on the bottom. Overall, it's 3. And that completes the question. Okay, this is, again, a very weird little objective, right? Okay, classifying expressions to see if they're length, area, or volume formulas. Have a go at the question set and see how